Hi, this is Steve Smith, and in this Pluralsight on the main module, we're going to look at one of the fundamentals of software development, which is the interface segregation principle. The interface segregation principle represents the letter I in the SOLID acronym of Principles of Object-Oriented Design, and applying it can help you create projects and applications that have fewer hidden dependencies and are more cohesive and easier to maintain. In this module, we'll begin by defining the interface segregation principle and see why it's a problem when it isn't followed. We'll look at some examples of classes that have too many dependencies because the interface segregation principle was not followed, and these classes were forced to depend on fat interfaces. Once we've analyzed the example and found what the problems are, we'll refactor it in order to apply the interface segregation principle and result in a better, more maintainable design. Finally, we'll look at some tips for when and how to apply the ISP principle, and finally some related fundamentals, and wrap up. So the interface segregation principle basically states that clients should not be forced to depend on methods that they do not use. This comes from the excellent book Agile Principles, Patterns, and Practices in C#. The corollary to this, of course, is that you should prefer small, cohesive interfaces to fat interfaces. I really like these motivational posters. You can actually put them up in your team room if you like, or in your cubicle. This one is the interface segregation principle, of course, and says, you want me to plug this in where? The idea here is that we have a very small dependency that we require, which is this upper left USB cable here. But instead of being able to simply plug that into a USB port on a computer, let's say, instead we're being forced to haul around this large dependency represented by whatever this widget here is, that has knobs and switches and buttons, as well as Hi, this is Steve Smith, and in this Pluralsight on the main module, we're going to look at one of the fundamentals of software development, which is the interface segregation principle. The interface segregation principle represents the letter I in the SOLID acronym of Principles of Object-Oriented Design, and applying it can help you create projects and applications that have fewer hidden dependencies and are more cohesive and easier to maintain. In this module, we'll begin by defining the interface segregation principle and see why it's a problem when it isn't followed. Look at some examples of classes that have too many dependencies because the interface segregation principle was not followed, and these classes were forced to depend on fat interfaces. Once we've analyzed the example and found what the problems are, we'll refactor it in order to apply the interface segregation principle and result in a better, more maintainable design. Finally, we'll look at some tips for when and how to apply the ISP principle, and finally some related fundamentals, and wrap up. So the interface segregation principle basically states that clients should not be forced to depend on methods that they do not use. This comes from the excellent book Agile Principles, Patterns, and Practices in C#. The corollary to this, of course, is that you should prefer small, cohesive interfaces to fat interfaces. I really like these motivational posters. You can actually put them up in your team room if you like, or in your cubicle. This one is the interface segregation principle, of course, and says, you want me to plug this in where? The idea here is that we have a very small dependency that we require, which is this upper left USB cable here. But instead of being able to simply plug that into a USB port on a computer, let's say, instead we're being forced to haul around this large dependency represented by whatever this widget here is, that has knobs and switches and buttons, as well as multiple USB ports. and is basically way more than we need. It does provide us with a USB port that we can plug into, but it also requires a whole lot more stuff that we don't actually care about. So when we talk about the interfaces that we're supposedly segregating with the interface segregation principle, it's important for us to further define what we mean by an interface. Of course, in C#, an interface is a reserved word and represents a non-implementable type that specifies a public set of methods and properties that must be implemented by anything that chooses to implement that interface. However, it's also the public interface of a class. So any class, any type, whatever its public interface is, whatever its public methods and properties are, if these are things that are used by some client, and it only requires the use of some small subset of those things, it's possible that you would end up with a better design if you were to segregate that class in some way that made it so the client didn't need to use as much of it. An example of this would be the classic design pattern, the facade pattern, which basically lets you take a large class or a set of complex classes and replace them with a much simpler class that offers only the subset or interface that the client actually needs. Let's go ahead and look at an example showing how violating the interface segregation principle results in a worse design. Let's take a look at a real example first. This is the ASP.NET membership provider that ships with ASP.NET 2.0. So the base type here is membership provider, which is defined in system.web.security.membership-provider. And this is what's used out of the box for things like the SQL membership provider that many websites are built on today and allow you to leverage the login controls and forgot password control and other things out of the box with ASP.NET 2.0 or later. One of the common criticisms of the membership provider, though, is that it has a very fat interface. In fact, it has quite a large interface. If we look at this very, very simple implementation of the membership provider, where we have not yet implemented anything at all, you can see that just to fill out this set of non-implemented exceptions for each method property is over 100 lines of code. Now, if we look at some of the classes that utilize this interface, this membership provider type, we can consider the login control from, again, the ASP.NET world. And here we have the system.web.ui.login control. And specifically, we want to look at this method here. So we have a method that's aptly named authenticate using membership provider. And this calls a little utility called loginutil.getProvider, which fetches current membership provider. And that method is shown here. You can see it's not doing anything too special. It's just grabbing whatever the currently configured provider might be. And then the part that we're interested in is right here. Once it's gotten a membership provider, this type here that's returned by the static method, the method that it calls is validate user. Now, if we look at all the rest of this class, we'll find that this is in fact the only reference to the membership provider that the login control has, which makes sense because obviously the login control is a very cohesive control. It's very tightly focused. It has a single responsibility pretty much of validating user. And so it would make sense that it would only need to call this one method, and that it would only need to be concerned with passing that method the two things that it requires, which are, of course, the username and the password. But if we want to leverage the login control in our ASP.NET website, and we want to do so with our own custom membership provider that talks to something other than SQL, or we write our own version of the SQL membership provider, or we talk to Oracle, or we talk to Facebook, or whatever, we're going to have to implement the membership provider interface because the login control depends on membership provider and not on, for example, an iValidate user interface that would be specific to what it actually needs. Now, moving away from this example of ASP.NET membership, because it would be rather time-consuming to actually work with this large interface, we're going to work with another example that's still very practical. In many of my applications, I use a Figuration section in order to define some of the common settings. I think most developers in .NET do this as well. If we look at a very simple implementation called About Page, that you can imagine might exist in an ASP.NET application with some modification, of course. You can see that it's taking in a text writer, and then it's going to basically write out the current application name and who wrote it, the author name. Now, it's not going to hard code these things. It's going to do this in such a way that it's reusable and configurable. And so it's going to use this configuration settings class in order to achieve this. Now, of course, this application does a lot of things. So this configuration settings class has grown somewhat large over the course of time of building this application. Let's have a look at that class. So the configuration settings class inherits from Configuration Section, which means that we can use it to read from the web config or app config file of our application. It has some boilerplate code in here whereby it exposes a static settings property, which is of its own type, and when called, we'll go ahead and give you a loaded up version of this setting. We also take advantage of some nice features with the attributes here, where we can specify that some of these configuration settings are required, and these will actually be enforced at runtime when someone attempts to retrieve one of these properties. The actual implementation of all this is beyond the scope of a talk on the interface segregation principle, but if you are using .NET, it's worth learning how this stuff works with the configuration property. So if we look at a summary of these types, we'll see that we got an application name, an author name, a castration, database server name, database username, database password, and a web service-based URI. These are all the things that represent my settings for my application. The way this has been implemented, it also is using a configuration file. So you can see that I've defined my new section here called Configuration Settings, and I have all of the settings specified here with their default configuration. Now with this in place, everything actually works. I can go into my About Page tester called About Page Should, and I can say About Page should display the application name. And if I run this, we should get a green light, and we do. So what this is basically saying is that I expect to get interface segregation by Steve Smith as my output when I call aboutpage.render, and I don't pass it in anything. So we are a default constructor, but we have a note here that says this is hard to test. We have to have app config in order to test this. If I go and I take my app config and I remove it, or I change the name of anything in here, so I change my name to Steve Smith 2, and then I want to rerun my tests, we find that this is going to be very brittle, because now we're going to see that it failed. Steve Smith was expected, but we actually got Steve Smith 2. So the problem with this is that when you start relying on these configuration files throughout your code, two things happen. One, you've got dependency on a file, which means your unit tests are much more brittle and more difficult for multiple different users to have working correctly on their own machines. And the other issue is that now we've got a bunch of stuff that we have set even though we didn't need it. So, for instance, in order to do all this testing of the About page, I had to go into app config and I had to also put in settings for castration, database server name, and all this other stuff that I really don't care about at all.